Hello everyone, I am Professor Ayiswarya. So in this lecture video, I am going to explain about module number 5, kinematics. So under the kinematics topics, we are going to see about the types of motion and the derivation of motion. So the important three types of motion we will be seeing in this lecture video. Along with that, the equation of motion derivation. So guys, we shall see about that in the upcoming slides. So, when coming to types of motion, there are three important types of motion that are rectilinear motion, curvilinear motion, and projectile motion. So, what does this means? Guys, rectilinear means the equation in the straight line is called as a linear motion or a rectilinear motion. When the motion is not in the straight line, it is in the curved path, means it's called as curvilinear motion. Okay, when the motion is a combination of straight line and curved path, it is said to be projectile motion. Okay, so guys, so these are all the different types of motions which you will be seeing in the upcoming presentation. Okay, so our thing is like without the equation of motion derivation, we cannot like these three types of motions are fully of like equations of motion only. You have to use the formulas of equations of motion, and with respect to some signs, that is like when the motion is in downwards direction it's positive and upward it's negative, like that you have to consider the gravity. Okay, so everything based on that, like you have to apply the formulas for rectilinear, curvilinear, and projectile motion. So in the curvilinear, you will be studying about the angular velocity, angular acceleration, angular displacement, everything. Okay, in the rectilinear, you will be learning about the same types which we are seeing earlier, like velocity, displacement, acceleration, everything. When coming to the projectile motion, you will be seeing only about the options like a trajectory, a velocity of the body, velocity, and the range, distance, and time, like that you will be seeing very simple terminologies in the projectile. Okay, so we shall see about equations of motion derivation, which is the root cause of all the kinematics problems, and we can use only that for solving the numericals. Okay, so here is the derivation of equation of motion. So it says that the rate of change of velocity is equal to acceleration. Guys, when velocity v is the velocity and a is the acceleration. So we know that the mathematical expression a is equal to dv by dt. Okay, whereas dv is equal to a into dt. That we know it, right? So for this you have to apply the change of time, that is integration of u to v and integration of 0 to t. Okay, if you apply over it, after integration what will happen means you will get v minus u a. See guys, this is 0 into a is 0, so you will get only at. Okay, u is the initial velocity, v is the final velocity, a is the acceleration, t is the time taken. Hence, we know that v is equal to u plus at. Okay, so this is the derivation of equation of motion. First derivation, which is the equation number 1. Okay. Okay, so now we'll see the second formula how to be derived. Okay, so in the second one, we know that rate of displacement is equal to velocity, isn't it? So the mathematical expression for the rate of displacement is ds by dt is equal to v. Okay, ds is the small distance and dt is a small time, isn't it? So ds is equal to v into dt. So we know that v is equal to u plus at. So substitute u plus at into dt. So you will get u into dt, at into dt, where u is initial velocity, dt is small time, a is acceleration, t is time taken, and dt is the small displacement. By integrating the above formula, you will get, so for for ds, if you integrate, it will be 0 to s. So for u, if you integrate 0 to t, and for at dt 0 to t. Okay, if you integrate it, 0 into s will be 0, so you will get only s, which is equal to ut plus of at square. So the first equation is uv is equal to u plus at, and second equation is s is equal to ut plus of at square. Okay. So guys, we shall see about how to derive the third equation of motion. Okay, so we know that the distance traveled is in time t. Okay, so let initial velocity is u and the final velocity is v. What is the distance formula? Average velocity by time. See guys, velocity is equal to distance by time. So the same thing you are writing like this. Okay, so average velocity into time. So s is equal to average velocity is what? It's an initial velocity plus final velocity by number of instances, isn't it? Okay, v plus u by 2 into t. Since you know that u is equal to, see, v is equal to u plus at, then substitute over it in this formula. So you will get s is equal to u plus at, and substitute t is equal to, see guys, the same only they are writing like t is equal to v minus u by a. In the above equation they are going to substitute t is equal to v minus u by a in the above, s is equal to v plus u by 2 into t equation. Okay, if you solve over here, you will get v plus u by 2 into v minus u by 2, which is v square minus u square by 2a. Okay, so if you take this 2a denominator to the nominator, you will get 2as is equal to v square minus u square. The same thing if you, okay, just rearrange, you will get v square is equal to u square minus 2as. So this is the third equation of motion. So you will get three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square minus 2as. So these are all the three equations of motion that should be known before entering into the numerical, guys. So this you will be using for the equation of motion for rectilinear numericals, okay, for curvilinear and for projectile motion the same, but the terminologies will differ. So this is how you need to you need to get the values. Okay guys, so this is the derivation of equation of motion. So in the next lecture video I'll be explaining about other types of motion, guys. So thank you everyone.